there's an overtime. After there was the exchange of balls, so now it's sudden death overtime. They kick a field goal from 50 yards, of course, as it must be, and 40 yards out plus the 10 plus the height distance. So it's like 52-yard field goal, and there it was. And if there's 10, right, everybody's silent, and the ball comes up, and it careens off the left upright and goes in for the win.
Wow.
And I said,
I remember this.
That's what I'm saying.
I remember this
That's
week.
what I'm saying. So I said, wait, the angle of this, how long is it? So I checked the stadium, its configuration was longitude and latitude, and I said, I did a quick calculation, and I tweeted, the winning field goal in that game was aided by a 1/3 of an inch deflection to the right from Earth's rotation.
Hey, Australian people, have you ever been in the Northern Hemisphere? Have you ever noticed whether your toilet drains differently than it does here? No? You heard maybe it has something to do with Coriolis effect? Welcome to another edition of I Don't Think It Means What You Think It Means. You probably don't spend a lot of time thinking about how water drains from your toilet, but somehow the idea that water drains differently in the northern and southern hemispheres has made its way into our collective consciousness. Furthermore, the reason for this phenomenon has been pinned to the Coriolis effect, which refers to the way the Earth's constant eastward rotation influences how we view the trajectory of certain moving objects. Because the diameter of the Earth at the equator at 40,076 kilometers is so much greater than it is at the poles at 0 kilometers, the land of the equator is moving lots faster than the land everywhere else, about 1,638 kilometers per hour at the equator compared to about half that at 60 degrees north latitude and pretty much stationary at the poles. And yes, the Coriolis effect, named for 19th century mathematician Gustav Coriolis, does indeed influence objects traveling across the face of the Earth due to this constant eastward rotation. If you tried to throw a baseball from the equator up to your friend standing at the North Pole, your ball would appear to veer to the right because it would maintain the greater momentum of the place it started from. On the other hand, if you were throwing the ball to the South Pole from the equator, the ball would appear to veer to the left for the same reason. So although the Coriolis effect is totally a thing, the application of this principle to draining water in Earth's two hemispheres is just bunk. Our planet spinning around once every 24 hours isn't a big enough deal to affect a toilet that takes 5 seconds to flush. Basically, the direction water drains is dictated by the shape of the basin it's in, the sink or toilet bowl or whatever. The Coriolis effect does, however, influence bigger, slower moving fluids, global air and ocean currents, for instance, which can end up giving hurricanes their spin. If the Earth didn't rotate on its axis, among the very many and unpleasant things that would be different, one of them would be that winds wouldn't blow either west or east. They'd flow from the poles, which are naturally high pressure areas, to the equator, where there's low pressure, and back again. But the Coriolis effect deflects these winds to the right in the northern hemisphere, to the left in the southern hemisphere, which creates weather systems that rotate clockwise in the northern hemisphere and counterclockwise in the south. The Coriolis effect, working at that scale, does affect entire climate patterns, but it can't make itself felt on whatever you left in your toilet. Sorry. The Coriolis effect. Weather, not toilets. Got it? Good. Thank you for watching this episode of I Don't Think It Means What You Think It Means. If you
Of the Earth. Hurricanes and other cyclonic storms also do not follow the alleged Coriolis effect, with global wind patterns appearing to blow haphazardly around the ball. But when looking at the wind patterns on the azimuthal equidistant map projection, the weather patterns are found to consistently spin counterclockwise around the flat Earth, paralleling the rotation.
Here showing ocean currents. And you can move it around and check it, different angles and stuff like that. And the temperature is showing, the equatorial region and stuff like that. When you look at the currents, you can look at air currents or wave currents and temperature currents. When you look at it on a globe and you really start zooming in and analyzing things and how things are moving around, a lot of it doesn't make a whole lot of sense. It seems kind of random. When you do it on the flat Earth model, though, it starts making a lot more sense. What's doing what and why it's doing what's doing. Let me go here. This is air currents. Okay, notice how in what we would call the northern hemisphere, everything's going this way. The air currents are going this way, but in the southern hemisphere, the air currents are going this way. See?
Oh, okay.
Do you see what I'm saying? Can you?
Yeah.
Can you catch that? I wonder if that one's better. Let me try this. Yeah. So if this is what has been referred to as the ether.
As very young children, we are taught we are living on a sphere. We are later taught that the sphere we are living on is spinning. We are taught at an early age in school that every object that is detached from the dirt surface of the Earth is subject to the effects of the Earth rotating under said object. There are many arguments on YouTube claiming that this is not true. Let's take a moment to review exactly what we are taught in school regarding the Earth's assumed rotation under objects that are detached from the Earth's surface. Here is the teacher's guide to prove that what we are taught as fact in school is a very simple concept designed to reinforce our belief in the globe model. This teacher's guide to teaching the Coriolis effect clearly states that everything detached from the dirt surface is subject to the Coriolis effect. There is no difference between a baseball or a bullet. Coriolis cannot be a selective effect. If the Earth was rotating, and what we are taught in school as fact is indeed true, then the Earth would have to rotate under all objects that are detached. It is that simple. The same applies to an airplane. The only difference between a bullet and an airplane is that a bullet can only fly in one direction. An airplane is capable of flying under its own power with or against the assumed rotation of the Earth. The entire premise of the Coriolis effect from a meteorological standpoint is that the rotation of the Earth under the atmosphere is what causes directionality differences in hurricanes both north and south of the equator. So, with that being said, an airplane that is detached from the Earth's surface should now be subject to, and bound to, the same atmosphere that meteorology claims the Earth rotates under. With these two things in mind, my common sense tells me that there should be a significant difference in flight times between west to east and east to west flights. But there is no difference. At best, flight times differ only by a few minutes and usually only due to the effects of wind, direction, and velocity. If all runways ran east to west or west to east, then the Earth's rotation would not be too much of a problem. It would be like landing a jet on an aircraft carrier, only a much bigger jet full of passengers. However, runways do not all run east to west or west to east. They run north to south and south to north and everything in between. This is a problem for the globe model as taught in school. So, what you need to ask yourself is this. What does your common sense tell you about the expected effects resulting from an airplane flying with and an airplane flying against the assumed rotation of the Earth? Your opinion is the only one that should matter to you. Rod Furlong, longest kill shot in history, 1.5 miles. Furlong's weapon, the Macmillan TAC-50, a sniper rifle with a max effective range of 2,190 yards.
Because the air's getting thinner, so therefore your muzzle velocities are increasing, your time of flight is actually shorter from distance further down.
It's played a huge factor with our hit ratio, a lot of one-round hits. Reason being is we're dealing with, at times I remember, at least 3 crosswinds, and you just wait for that perfect moment. It's great if I can get the winds to die out, but how many times does 3 crosswinds die out? They don't.
Furlong runs out of his Canadian-made ammo.
We had somebody offer us American-made ammunition, and when we started using it, we noticed that it was a hotter round. We're getting a lot longer distances out of this round. Whether that round was a lighter round, whether it was a faster burning propellant, I don't know. Every shot that we made was new for us.
Whether the U.S. rounds are more aerodynamic or simply have a faster burning propellant, the results are dramatic. Furlong and his team take out enemy targets more than a mile away, but his longest shot is yet to come. The Shaw-E-Cote Valley, mean altitude 9,000 feet.
When somebody's walking on the river valley floor, I'm up at 8,500 feet. I'm looking down. It's almost like being on the clouds looking at someone. My partner lays the target, gives me the distance. He starts to give me bearing, wind direction. It's everything I'm using to enter in data into my scope, or in this case, what am I going to do to be able to reach that range.
Furlong looks for any way to get more distance on his shot. He resorts to an old sniper trick.
It was a very warm day. We had our ammo laid out in the sun. Anything to increase range, it's not going to make a huge difference, but it will make a little difference for how propellant acts, a faster burn, allowing the round to travel slightly further.
Because of the extreme angle and the distance, Furlong uses the ambush method, leading the target or allowing it to walk into the path of the bullet.
I max out my elevation drum. My windage is maxed out. So I'm halving up my scope. And what I mean by that is I'm leading with my mil dots, but I'm also using my mil dots for elevation as well. So I'm kind of halving my scope to where I believe my point of aim is. When you have a scope, usually this is what everybody's thinking about for a point of aim. If I'm leading a target and I have a target walking from right to left, he's walking and I'm waiting for him to hit this point right here. Once that target is at my point of aim, that's when the shot's released. That's an ambush. You're not releasing on the crosshairs. This is what you're using for a point of aim, and that's 1 mil. Basically, with a 4 mil lead, and 4 mil for elevation, your point of aim roughly would be in this area.
Furlong aims 4 mils, or roughly 15 feet above, and approximately 4 mils, or 15 feet to the left of his target. These holes compensate for bullet drop, wind, and spin drift. To the left of his target. These holes compensate for bullet drop, wind, and spin drift. Furlong steadies himself, takes aim, and fires. Furlong's spotter follows the vapor trail or swirl of the bullet on his first shot, then observes the splash or dirt kicked up by the round as it hits the ground.
To quantify that, if you can imagine, the observer watched a 50 caliber bullet at 1.5 miles away impact the ground, and then he called adjustments from where the bullet landed to where he knew the bullet had to be to hit the enemy.
1.5 miles separate Furlong and his target. Rod Furlong's 1.5 mile kill shot shatters Carlos Hathcock's previous record by 157.
I don't know if they just thought that today was a lucky day, but it wasn't.
Viewer discretion is advised. Go where no man has gone before.